Hi, I'm Jeff DeAngelis, Managing Director of Industrial and Healthcare Business Unit from Maxim Integrated. And this morning or afternoon, depending on where you are, we'll be talking about empowering intelligent automation and motion control. Industrial convergence is driving discussions around automation industry, calling for more intelligent and at the edge types of devices. As a result, a new way of thinking is needed to translate semiconductor solutions into products that provide better real-time information so that AI algorithms can be used to optimize an entire factory as well as its individual machines. In order to accomplish this level of automation and flexibility, every aspect of the equipment needs to evolve. In the area of motion control, there is a need to develop smart actuators. These smart actuators will provide the necessary control of the flow and speed in which a product is moved through its operations. Since all applications require their own unique set of motion control and motor drive, these smart actuators will need to provide higher efficiency to limit power dissipation and enable smaller sizes, better control of position and torque, as well as the ability to self-tune and optimize their performance while in operation. This combination of smart integration will enable a new class of products to meet the demands of Industry 4.0 and beyond. If we do a simple Google search on the key elements needed to achieve industrial convergence, the amount of information obtained is staggering. The four fundamental elements required to achieve industrial convergence are the Industrial Internet of Things, cloud computing, adaptive I/O, and artificial intelligence or AI. The search from the first three elements of industrial convergence results in finding 1.4 billion articles, while the topic of AI alone netted more than 2.3 trillion articles. Needless to say, the volume of articles written around these four essential elements of industrial convergence suggests that the momentum is building as many companies strive to create intelligent manufacturing facilities that improve manufacturing throughput, efficiency, and the reduction of operational costs. These intelligent factories will provide real-time communication via 4G or 5G networks to receive and confirm orders using web-based apps. It also provides the necessary flexibility to customize orders by leveraging powerful real-time decision-making that enables cloud-based information gathered from a host of intelligent manufacturing machines, robots, and intelligent sensors that form the Industrial Internet of Things. This sounds like a pipe dream, but companies involved in automated warehousing of goods and services have brought this vision of industrial convergence to life. Imagine an automated warehouse that can pick a 50-item order in a matter of minutes, while updating inventory mix and replenishing through AI and machine learning that predicts changes in customer preference and ordering behavior from its inventory of 50,000 SKUs. While this is a great example that shows a level of industrial convergence, consider the net impact of picking the wrong item and shipping it in the box to the customer. This mishap ends with a single frustrated customer who needs to ship back the item. Now imagine a mistake made at a nuclear power plant, misjudging the cooling water level of the reactor or opening the wrong valve on an oil processing rig. This could result in the meltdown of the core, causing a radiation hazard or dumping millions of gallons of oil into the water. It's safe to say that the stakes are higher in these process automation examples if a bad decision is made by an automated system governed by an AI algorithm. The immediate challenge is to achieve a higher level of performance where AI and decision-making are done in real time at the edge of the manufacturing line, where equipment can be monitored and actions taken immediately to improve environmental and human safety. If we venture to take this concept one step beyond, then the technology needed to support this level of real-time intelligence at the edge requires a new class of nimble products that provide real-time information to enable better edge-based decision-making.